Hello guys, in today's class we'll discuss the first clustering algorithm, that is K-means clustering or K-Medoid clustering. Okay, so first we discuss K-means clustering. Okay, in K-means is a particular clustering algorithm. Let the set of data point or instances D that it will be, suppose it is the feature x1 to xn, where xi equal to xi1, maybe xi2, maybe xir, is a vector in real value, that is x subset of r to the power r, and r is the number of attribute dimension in data. Okay, so here the k-means algorithm partitioner given data into k cluster. It will divide into k cluster. Each cluster has a cluster center that is centered. Okay, as each cluster have a center. That is, suppose it is a, okay, it is one of the cluster. Then this cluster have also a center, and this cluster have a center, and this cluster have a center. Okay, here k equal to 3 because here cluster 1 and cluster 2 and cluster 3 like this. Okay, so okay, so we'll now discuss k-means algorithm. Okay, that is the step of k-means algorithm. If you discuss the step, the first step is initialize the value of k, the value k or centered. Okay, a second point is point nearest to the centered. Centered will be grouped. Okay, and third point is move to the centered or mean. Okay, move to the centered or mean and repeat this process. Repeat this process until you get a specific group. How it will be, we follow the step by step. We'll give a real life example. Okay, with mathematical solution. Okay, so how do we set the k value? You have doubt. How do we set the k value? Okay, so there is a formula that is double CCC equal to summation I equal to 1 to k and distance between the point to the nearest center. Distance between the point to the nearest centered. Okay, the whole square. It is the formula of double CCC. Suppose I give you it graph. Suppose it is a graph. mm, Okay, okay, and it is also another graph like this. Okay, so there is two graph and some point is there and some cluster is like this. Okay, and some cluster is like this. Okay, if you draw the line like this, it is one, it is also one, it is one, it is one, it is one, it is one, like this. It is the distance between point to the nearest point, that is the nearest center. Okay, similarly, If you calculate, it is your double CCC and it is your mm, suppose K. Okay, if your value is K 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. According to this formula, if you draw, okay, double CC, you mark, okay, at some time, okay, this elbow method, you notice it will be like constant or state, okay, and decrease, decrease, decrease like this. After some decrease, it will be constant, and it is your k value. That is here k equal to 5. Okay, according this, you will decide the value of k from this graph. Okay, so now if you decide the value of k like this, so there is a problem. If you take large value of k, if you take, okay, if you take large value of k, then overfitting will occur. Then overfitting will be occur. Okay. So for this, we'll initialize, that is the random initialize k. Random initialization trap. That is k means plus plus. Okay. It is the sum advantage of k means. Okay. If you draw, okay, when initialize centroid, okay, it will be maximum distance, maximum distance, okay, between them. So suppose if you decide the centroid like this, there is also cluster, there is one cluster, there is one cluster. If you decide one centered in here, then it will maybe convert these to one cluster. So for this problem, we'll decide the initialize the centered, it will be maximum distance between them. So if you decide the centered, that is here one centered, here it distance, and this distance will be maximum, always maximum. So there is no problem in selection of center. Okay, if the distance between two cluster center is maximum, okay, it is your k means plus plus. Okay, now we discuss with a mathematical example, that is there is some, suppose example here 8 point are given. Okay, now we will convert this 8 point to a cluster. Okay, suppose it is your initialized centered. Okay, so initialize centered, okay, and it is your data point given, and suppose it is your distance you calculate stance, you initialize the center. First point is initialize the center. Here you assume suppose three center, that is A1, B1 and C1. You assume three centered. So first centered is 2, 10, Okay, 2, 10, and second center is 8 and 4, and third center is 1, 2. Okay, you draw the table like this for mathematical explanation of K-means algorithm. Okay, so here you calculate the distance of every point from this point. So you know the Euclidean distance formula. How will calculate it? Okay, the formula is x2 minus x1 whole square plus y2 minus y1 whole square whole root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so it is the formula for distance calculation. Okay, so if you calculate 210 to 210, the distance will be 0. Okay, so if you calculate from 210 to, suppose 1 210 BU82 A384 58. Suppose you assume it is 58. Okay, suppose this is 58. B1. Okay, that is 58. Okay, so if you calculate the distance from 210 to 25, the distance will be 2 minus 2. If you calculate like this, 2 minus 2 ro whole square plus 10 minus 5 ro whole square ro root. So equal to 0 plus 5 raised square, that is 5 raised square or root of 5 raised square, that is 5. So distance will be 5. If you calculated this like this, you notice the distance will be like this. So here 7.06, 7.21, 8.06 and 2.24. Okay, you calculated and match your answer with this. Okay, 5.8 if you calculated like this, 3.61 and 4.24 and 5.0. Okay, that is 5.8 to 5.8, that is 0 and 3.61 and 4.12 and 7.12, 1.41. This is also 8.06, 3.16, 7.28 on 7.21 on 6.71, 5.39, that is 12120 and 492 7.62. You calculated the distance of every point to center. Okay, three center. So now you notice which is minimum. You draw in this. So here you notice which is minimum, 0 and 3.61 and 8.6. So 0. So that is the centered one. So you like cluster 1. Okay. Here you notice which is minimum. You notice 3. So you write 3. Like this, here you notice 5 is minimum. So here you write 2. Centered 2. Okay. So if you notice here 0 is minimum, that is centered 2. If you notice here, which is minimum, 3.61, that is also 2. Here you notice 4.12. 4.12 means 2. Here you notice the cluster 3, that is 0. Here you notice 1.41, that is 2. Okay, it is your cluster. Okay, so now you will find the next step of continue this with the updation of centered. Okay, it is the step up. So how will it updated? You notice here for one, for cluster one, that is the point is 20, only 210. Okay, for cluster two, if you notice 2 point is there, not two, 1, 2, 3, 4, 5. 5 point is there. Which 5 point? That is the 8, 4. Okay, and 5, 8. Okay, and 7 5 and 6 4 4 9. For 3, you notice which point is present in cluster 3, that is 2 5 and 1 2. Okay, so here you notice for cluster 1 that is 1 point, for cluster 2 that is 5 point, for cluster 3 that is 2 point. So now you will calculate the centroid or mean of every cluster. Here 1 is present, so here for 1 there is cluster 1, okay, 210 is present. If you calculate for cluster 2, then the point will be 8. If you notice 8 plus 5 plus 7 plus 6 plus 4. Okay, 8 plus 5 plus 7 plus 6 plus 4 whole divided by total number, that is 1 2 3 4 5. Okay, second y 4 8 5 4 9. Okay, 4 8 5 4 9 whole divided by 5. That is your 6 6. If you sum and divide by 5, then you calculated that is the centroid 2 is 6 6. Similarly, if you calculated for cluster 3, that is 2 point, that is 2 plus 1 by 2 and 5 plus 2 by 2. If you calculated this, it will be your 1.5 and 3.5. Now you draw this process, repeat with the updated centroid. That is, first centroid is 210 and second centroid is 6 6. Okay, and third centroid is 1.5 3.5. Okay, so here you notice the new centroid will be, that is, first one is always same 210. Okay, next one updated is 6 6 and last one is 1.5 and 1.5. So 3.5. Okay, 3.5. Okay, and previous cluster was, how the cluster was 1 3 2 2 2 2 3 2. So here we write this cluster like this: 1 3 2 2 2 2 3 2. Okay, this process will be continue. You mark your old cluster and new cluster will be same or not. If same, you can stop. If not same, then you proceed this process until the cluster or new cluster does not equal. Here you notice, here you calculated. If you calculated this, the output will be here 0 0.0 same. Okay, 5.0, 8.49, 3.61, the distance 7.07, 7.21, 8.06, 2.24. Similarly, here 5.66, 4.12, 2.83, 2.24, 1.41, 2.00, and 6.40, 3.61. Okay, here if you calculated, that is 6.52, 1.58, 6.52, 5.70 and 5.70, 4.53, 1.58, 6.04. Here you mark which cluster is present. 0 point, so cluster 1. Here you mark which is minimum, that is cluster 3. Here you mark which is minimum, that is cluster 2. Here you mark which is minimum, that is also cluster 2. Here you mark which is minimum, that is also cluster 2. Here you mark cluster 2. Here you mark which is minimum, that is cluster 3. Here you mark which is minimum, that is cluster 1. Now you mark here 1 1 equal to, here 3 3 equal, here 2 2 equal, here 2 2 also equal, here equal also, here equal also, here equal also. But in this there is change. So here cluster 2 in old cluster, but now updated new cluster is 1. So now we proceed this process until this old cluster and new cluster are not equal. Okay, so now we will calculate the centered one, or that is A1, suppose centered one. How? Which is present in centered one? If you notice, two present, that is 2 point, that is 2 5, okay, sorry, 2 10 and 4 9. So 2 plus 4 by 2 and 9 plus 10 by 2. So that will be updated center is 3 and 9.5. Similarly, you will calculate that the centered center will be 6.5 and 5.25, and third centered will be 1.5 and 3.5, because third center is only one. Okay. So similarly, if you do this process, you mark here the old cluster or update equals to 1 3 2 2 2 2 3 1. Here you write simply 1 3 2 2 2 2 1. Sorry, here you mark. Okay. So mark 1 3 2 2 2 2 3 1. Present is old cluster. Here you mark after calculation, the new cluster will be 1 3 2 and 1 and 2 2 3 1. Here you mark, here it changes. So updated again. Okay, if you updated again, the old cluster was 1 3 2 1 2 2. You do this calculation. I skip for EU. You will calculate it and mark your old cluster and new cluster for your practice. Okay. If you done for one time practice, then you completely remember what is K means clustering, how it works. Okay. So you mark a new cluster is 1 3 2 1 2 2 3 1. So here you mark all are same. Okay. So here you stop. Okay. And write your answer. In cluster 1, the point is present. Simply you write in cluster 1, in your first cluster, the point will be present. That is, you mark here A1, B1, C2. A1, B1, C2. And for second cluster, the point is present in second cluster, that is A3, B2, B3. And for third cluster, the point is present C1, A2. Okay, now you can draw this point, that is first point is 2, 10. Suppose you draw in this line, okay, 2, 4, 6, 8, 10, 12. Okay, 2, 4, 6, 8, 10, 12. Here simple you like 2, 4, 6, 8, 10, 12. Okay, 2, 4, 6, 8, 10, 12, like this. So first is A1. If you draw the A1, A1 will be, your point A1 is, here would have is 210. Okay, so 210 is present in here. Okay, second is A2. If you draw every point, A2 is 2, 5. So here present. Okay, and if you do 8, 4, that is present in here A1, A2, A3. Okay, similarly B1, B2, B3, if you do, B1 is 5, 8, B1, and B2 is 7, 5, that is 7, 5, Okay, B2 and B3 6 4, B3 6 4 and C1 is 1 2 and C2 is 4 9. Okay, now if you draw the cluster, first cluster is A1 B1 C1. A1 B1 C2. So you mark A1 B1 C2 is this cluster. So it is one of the cluster. Okay. Similarly, if you draw A3 B2 B3, A3 B2 B3, that is one cluster. And third cluster is C1 A2. So C1 A2 is another cluster. So it looks like a cluster using the K-means clustering. Okay. It is the totally mathematical explanation of K-means clustering. If you have any doubt in any concept, you ask in Telegram, also you ask in the comment section. Okay. So after that, if you random selection of K or random selection of K, you draw the two clusters like this. A cluster assignment, that is the recompute center. Okay. After that, these are the simple example of clustering. Okay, that is the cluster assignment. Then recompute the centered. After cluster assignment, that is also recompute the centered. Okay, so strength of K-means. What is the advantage of K-means? So it is simple and easy to understand and easy to implement. Easy to understand and easy to implement. So here the time complexity TK. Okay, where n is the your number of data point and k is the number of cluster and t is the number of iteration. So since both k and t are small, k means is considered as a linear algorithm. So k means is the most popular clustering algorithm in machine learning. Okay, so note that it is terminate at a local optimum if SS is used. Okay, the global optimum is hard to find due to complexity. Okay, so weakness of K means has some disadvantage like the algorithm only applicable if mean is defined. Okay, for categorical data, K mode, the centered is represented by most frequently value. The user needs to specify the K. If you not specify the K value or not calculate the K value, then we will not proceed for K means algorithm. The algorithm is sensitive to outlier. If some outlier is present, then if some outlier is present, suppose it is clustering. Okay, and some outlier if is present, okay, it is one outlier is present, then centered will be like this. Here will come centered. Okay, for this outlier. So if outlier is present in data point that are very far away from other data point, outlier should be error in data recording or some special data point with very different value. Okay, that is robust to outlier. K means algorithm. Okay, here you notice the outlier is present here. Okay, so the centered will be here. If outlier is present here, that is the ideal cluster. So it is two cluster, one cluster. Then the outlier present in this cluster. Okay, so, to deal with the outlier, one method is to remove some data point in the clustering process that are much further away from the centered than other data point. To be safe, we may want to monitor this possible outlier over a few iterations and then decide to remove them. For removing this outlier, we follow this method. And another method is to perform random sampling. We'll define the K means plus plus. K means plus plus. Okay. So assign the rest of the data point to the cluster by distance or similarity comparison or classification. Okay, so you notice here the initial seeds are like this. If you do some If you define the iteration 1, this is the cluster 1, this is the cluster 1, and this is the center of this cluster. Okay, so witness here is an example. Here the k-means clustering will be fail. The k-means algorithm is not suitable for discovering the cluster that are not hyperellipse or hypersphere. Okay, here if you define the cluster, how will define? Maybe it will be one cluster, maybe it will be another cluster. Okay, so here it cannot be defined. Okay, so next we will discuss now K-Medoid. Okay, so K-Medoid is same as K-means. Only difference is a method is a point in the cluster. Okay, from which some dissimilarity with all the other point in the cluster are minimal. Okay, a method is a point in the cluster from which the dissimilarity with all the other point at the cluster are similar. So method is a point in the cluster. Okay, from which the sum of the distance to other data point is minimal. Okay, sum of the distance to other data point is minimal. Is minimal. It is your method. So instead of centered as reference point in k-means algorithm, the k-method algorithm takes a method as a reference point. Okay, so if you the difference between k-means and k-method, so both method are types of partitioning clustering and both are also unsupervised clustering and have to deal with unlabeled data. Both algorithm groups n object K cluster based on similar test where K is predefined. Here input is unlabeled data and the value of K also. Okay, and here we will use K means Euclidean distance for matrix of similarity, but here we will use Manhattan distance. You know what is Manhattan distance? What is? We'll discuss in last class. That is, suppose you calculate the distance between A to C. How to calculate? A to C equal to AB plus BC. That is, if x1, x2 are 2 point, okay, and y1, y2 are another point, calculate like this. So the x1, y1, it is x2, y2. Okay, x2 minus x1 mod plus y2 minus y1 mod. Okay, it is the Manhattan distance. And clustering is done based on the distance from center. Here we will use the center and here we will use method. A center can be data point or some other point in the cluster and the method is always data point in the cluster. Okay, so cannot cope with outlier data. It is also manage outlier data. So K method manage outlier data. But in K means does not manage the outlier data. Sometimes outlier sensitivity can run out to be the useful and tendency to ignore meaningful cluster in outlier data in method. Okay, it is the some difference between the K means and K method. Okay, so thank you. Next class we'll discuss another clustering algorithm. Okay. So